Imagine walking into a forest where every tree seems to be telling a secret. Because in the heart of Siberia, near the isolated Tunguska River, there is such a place, where trunks lean like startled witnesses, where rings inside ancient larches thicken abruptly, and where for more than a century scientists have argued over the same haunting question: why did the trees start growing faster after the sky exploded? It begins on a quiet morning in 1908. A hunter named Semyon rows across the river, listening to the soft lap of water against the hull. The tiger is calm, so calm he can hear insects buzzing. And then, in a burst of white fire, the heavens split open. A shockwave rips across the land, flattening 80 million trees in a single breath. The blast lights the sky brighter than sunrise. Semyon is hurled from his boat. When he looks up, the horizon is burning. For decades afterward, the region remains almost untouched, a scar of fallen trunks and scorched earth. But when scientists finally arrive in the 1920s and again in the 1950s, they find something unexpected among the devastation. The surviving trees, those far enough from the epicenter to avoid annihilation, are growing differently. Their rings widen dramatically, their branches stretch faster, even seedlings sprout with strange vigor, as if the forest is racing against time itself. This becomes the heart of the Tunguska tree growth anomaly debate. Some researchers insist the explanation is simple. The blast cleared the canopy, flooding the survivors with sunlight, less competition, more resources, faster growth, a natural response. But others shake their heads. Too fast, they say, too uniform. Growth spurts appear even in areas that weren't fully cleared. Some changes persist for generations, and radiation levels, though not deadly, are measurably unusual. Could a cosmic impactor have sprinkled isotopes into the soil? Could shockwaves have rewired the ecology in ways we don't yet understand? In the 1980s, a young biologist named Dr. Marina Petrov hikes through the regenerated forest. She stops at a larch, places her hand on its warm bark, and murmurs, "How did you survive?" When she calls it, the answer stuns her. The tree's rings triple in width right after 1908, and this pattern repeats across dozens of trees, miles apart. The debate deepens. Was it sunlight? Radiation? Chemical enrichment from the blast? Or something stranger, a clue about the nature of the Tunguska event itself? As decades pass, the forest continues to grow, reclaiming the place where the sky once fell. And standing among those trees, it's impossible not to feel the weight of what they've witnessed. Maybe the anomaly is proof of nature's resilience. Maybe it's a message from the past preserved in wood grain. Or maybe, just maybe, it's a reminder that some mysteries don't fade. They simply grow. If this story intrigued you, don't forget to like, share and subscribe to help the channel grow.